Hello friends, welcome to our fifth video on learning computer vision. In this video we are going to create an image from Numpy Array. So in the previous video we created a colorful image from numbers, but we used the pillow library. This time we are going to use the Numpy Array to create an image, and we are going to do some fairly powerful stuff. So let's get going. We'll be using Python for programming, and we'll be using OpenCV libraries here. So let's thank our sponsors, Kimavi.com for learning computer vision, and myguide.org for seeing tools powered with computer vision. So what are we going to do? We are going to make colorful images from Numpy. What is Numpy? It essentially is a collection of arrays, or it's a type of array, and it's very fast. So we are going to learn the power of Numpy arrays and why it matters to computer vision. So let's start with some school geometry. And here we have concept of x-axis and y-axis. So this is basic high school geometry. We are just doing a quick recap. So as you travel further east on x-axis, x increases. As you travel north on y-axis, y increases. And in the coordinate system, you can get a point. In OpenCV, the positive y is towards the south, so it's the opposite. But the positive x is towards the east. So when you're dealing with OpenCV, the 0, 0 will be in the top left of your screen. Let me grab some sort of pointer. Let's see if here's the laser pointer. So this will be 0, 0 in case of OpenCV, and then you go x towards the right and y towards the bottom, right? Hope it makes sense. So again, this is basic high school geometry. Let me get rid of this pointer from here, and let me see if I can grab a line. Here is the line, and let me grab a pen. So in case of OpenCV, the x will be like this, but the y will be going in this direction. Okay, this is y, this is x. Let me draw it over here. So y is going down and x is going over here in case of OpenCV. Okay, so let's get rid of these things. Control I. I don't know what is this command here. But anyway, so here we see 2 and 3. We are in a two-dimensional space. X is one dimension and y is another dimension. Alright, so this is just two-dimensional representation. But here is the three-dimensional representation, where you have x-axis, y-axis, and z-axis, right? So this is a three-dimensional space. So when you're displaying the blue, green, red pixel on a screen, essentially you have a three-dimensional array, and every point on the pixel is getting the blue value, green value, red value, and that's where the Numpy could be very useful. You can have three-dimensional or even four-dimensional values. What could be fourth dimension? Well, let's just say opacity. All right. So let's just recap what are we doing here. We just talked about some basic high school geometry, and now we are talking about three-dimensional spaces. And you should have a good idea what is the x-axis, what is the y-axis, what is the z-axis. And then here, if you notice the point 295, it's like 2 units on the x-axis. It's 9 units on the y-axis, and then it's the 5 units on the z-axis. Let me grab my line again and see if I can show you what we are trying to do over here. So Command S, Command K, Command I. What is it? How do I get the line here? Command arrow. Okay, now I can get the line with Command A. Anyway, so here is the line. We'll grab a pen. And then you can see here that we are traveling 2 on the x, we are traveling 9 on the y, and we are traveling 5 to get to this point. Okay, hope you got it. Let's press Command I to get rid of this mouse pointer. So we can write two-dimensional array like A00, A01. The array always starts with number 0, which is basically saying my 0th row and 0th column, or my 0th row and first column, or my second row and first column. Essentially, in a two-dimensional space, we can write arrays like 0, 0, 0, 1, and similarly we can write array in three-dimensional space, 0, 0, 0, 0, 0, 1, 0, 0, 2, and this values could be for blue, green, red in case of OpenCV, or it could be RGB if you are using Pillow or some other library. The important point is every pixel, like for example, you see a green pixel on the screen, you see black pixel, they are getting blue BGR values. The pixel is represented by a three-dimensional array, and essentially you have values of each dimension on that array. Hope it's making sense. Let's take a quick look at another example. Here is a Rubik Cube. If you haven't played with Rubik Cube, go ahead and play now. It's a lot of fun. If you enjoy playing with Rubik Cubes, you will love computer vision. And here you can see that like for each pixel on the Rubik Cube, there are numbers, and you can see numbers on the left hand side. So how can we show pixel on the screen in the BGR terms or RGB terms using numbers? 25500. Now this represents, in NumPy for OpenCV, a blue pixel, blue, green, red, and we'll show that to you using code in the next video. So what is NumPy? It's a multi-dimensional array which is super fast. So for example, if you use simple array in Python, it won't be that fast, but NumPy will be super fast because it's accessing the value in the memory which are next to each other. So why is it fast? I just explained, but the better answer is who cares? It's fast. Okay, anyway. So now how can you write a three-dimensional NumPy array with only blue pixel? Here is the code. You will have 3 brackets here. So this 3 brackets are for, the first one is for the NumPy array, the second bracket is for the row, and the third bracket is for the 3 dimensions inside that row. Here we have blue as 255, green as 0, and red as 0. And here is a simple Python program that's writing the same thing, and we are going to do that in actual code in the next tutorial or next video. But core idea is very simple, that we create a NumPy array, np.array. We assign it to a variable called image array, and then we put some numbers inside it, and we specify that it is a uint type of array, right? So here we are just putting value inside the array. This is the row, this is the first column value. There are 3 values against it, 0, 0, 0, 1, 0, 2, like 0, 0, 0, 0, 0, things like that. And then we'll print some values to see what is inside it. And then here we are showing that it is a 1 by 1 pixel and it only has 1 blue pixel. So we're actually going to do it using code, and I'll show you how this all fits together. Command L to get rid of our laser pointer, and Command I to hide our other arrows. So I'm doing PowerPoint on Mac, and I'm using some keyboard shortcuts. The keyboard shortcuts are a lot of fun. Learn them. Anyway, so let's see what is inside our image, and we can see what is at the 0th element, what is at the 0, 0 array element, what is at the 0, 0, 0 array element, and we are going to do some fun with what is inside my image. How many rows, how many columns? We can ask this question. How many channels in the image? Does it have opacity or not? These questions can be answered as well. So here are some tutorial slides, but I think once we write actual code, it will be much more interesting. And here is a code for writing three-dimensional Numpy array with one blue pixel, one green pixel, and one red pixel. And these are all going to come in this simple row, right? So here the yellow bracket represents the row, and the three columns in the white, the three brackets in the white represents columns. So this code is going to produce a 3x1 pixel, 3 in terms of columns, 1 in terms of row, and then each column would be blue, green, and red, because that's how we have coded it. And here is an example of how this all fits together. So we are going to use Numpy Array to create a 1x1 blue pixel. We are going to use Numpy Array to create a 3x1 pixel, 3 columns, 1 row, and in each column we'll give it color blue, green, and red, and we'll do it using the code. You can see the code right over here, but once we write it in Python it will be much more helpful. Alright, so let's just recap what we have learned, and let's get going with the coding. Alright, so what are we going to learn over here is how to use Python NumPy to create images with colors. It could be 1x1 pixel, it could be 1x3 pixel, 1 in terms of row and 3 in terms of column, or it could be also like 2 rows, and we can have 2 rows with 3 columns, something like that too. So here the 2 yellow brackets are for rows, and then the white brackets, the square brackets, are for the columns. And by just putting some numbers inside the NumPy, we can create colors. And if we want to make the shades of gray, we just keep the BGR as the same number. So again, we are going to write this thing in the code. This is just a tutorial video. I know it's getting boring. I'm getting bored here too. So let's recap and let's get going inside the code. So what are we going to learn, or what did we just learn this in tutorial? Any image in the world can be written on computers using just numbers. NumPy is a way to write numbers. It supports n dimensions. 1 dimension, 2 dimension, 3 dimension, 4 dimension, 5 dimensions, keep going. NumPy will support it, and it's super fast. We can write any color on computers using 3-dimensional arrays, and we can give it opacity by adding another dimension. And that's all. So hope you had some fun in this tutorial. Let's thank our sponsors, Kimavi.com and myguide.org. MyGuide has some amazing tools built using computer vision, and thank you for learning computer vision. It's one of the most exciting things in the world of computer science. In the next video, we will cover coding. Thank you, friends.